Welcome back again. So first thing I want to say is that this video is totally optional. What we're going to discuss is organizing your code into multiple files, which is something that big projects need in C development. For this class, the biggest project you'll do is your final project. Most of them do not need to get broken up into multiple files. Most of them, one file is just fine. But for like real projects, like the 10,000 lines of code, you can't put all that into just one .c file, right? So you can't do it all just in kind of one spot. So what you do is you have to make what some people call modules. It's a collection of a .c and a .h file. We've used these all the time with libraries, by the way. We include a .h file that defines what functions you can call, and then there exists somewhere a .c file. You've also seen it with like the LCD module that we talked about earlier. It was a separate .c and .h file, but you didn't write it. So what we're going to talk about today is creating these separate modules and show you how you can write them yourself if you would like for organization. If you don't think this is a topic that you'll be interested in, you don't think it's a topic you'll need, just stop watching the video. You will never be tested over this material. You'll never be quizzed over it. You're not accountable for it in any way. But if you want to know, let's talk about it. So where I want to start is I want to start by downloading a little template. So I'm going to go to the courseware page. And what I'm going to do is I'm going to download, make sure it's fresh here, supporting.c. So I'm going to right click on it and do a save link as. And you can save it anywhere you like because we're going to essentially move it. I'm going to save it into a folder here that I've got my other templates and LCD module stuff in. So I'm going to save supporting.c right there. And then I'm going to save supporting.h to the same spot. Cool, so now I have those two files somewhere on my computer. And I'm going to go into MPLab. And I'm going to create an additional template, which is something we haven't done since like the first day we talked about MPLab. So the place where this is at is it's under Tools, Templates. And in the .c area, we're going to add, we're going to go find that supporting file wherever you saved it to. So here's my supporting.c file. And so now it's in there, and then I also want to add supporting.h. So I navigated to where it's at, and so supporting.h, I want to add it as well. So now I've got those files that I can use at templates. So I'm going to add them to this project. I'm just going to go ahead and use my writing functions. I'm going to just continue it. So the way it works is first you have to say source files new, and we're going to add other because we've never added it before. And we want to add supporting.c here. We're going to show you how to leave it as the same name, and we're also going to show you how to change the name. This one we're going to leave it as the same name. We're just going to call it supporting.c. And then we're going to also do a include supporting.h. And notice that I did the supporting.h in the header file area. So now we've got this new file. Let's go ahead and take a look at it. Start with the header file. Supporting.h. So first off, it's got this like weird little semantic that says if not defined supporting.h, then define it. And then at the end, there's the end if. What this is it's a guarantee that it will only get included once in a project. That's not an issue for you because you're going to only have include supporting.h once. But this is standard protocol when you're defining a .h file to guarantee it's only included once. Things that are in the .h file are what's visible to the end user. So the things that are visible is we have a pound defined that will be visible to other people. We have a global variable, like a genuinely global variable. Note that it used this word extern, so that's a new keyword that makes something like global in all files. We've never had something global in all files. And then I've got one example function. It looks like it takes an int and returns an int. And you can see the documentation is not amazing. So first off, let's show that you can just use it right out of the box. So we would say pound include supporting .h. So as soon as I include supporting.h, then suddenly I have access to those files. So I'm just going to call that function. I'm going to say example function. No, I haven't even looked at the .c file at all. And I'm just going to make a place to store it. Looks like I've already got a variable called result in this one, so I'll just say result equals example function. If you didn't magically have result left over from something else, then you can make a new one. So I'm going to pass it in 5, and then I don't necessarily even know what this function does because the documentation was so far, but I'll just say result of function is %d. I'll add my \n, and I'll just print out result. So here I am calling the function. I'm showing how to use it. We haven't even looked at the implementation of it yet, though. But I should be able to run it, and it should return something to me. So if I go to the output UART, it says result of function is 10. I don't know if your eyes are good enough to see that, but result of the function is 10. So let's go look at what that function did. I passed it 5. It gave me back 10. This is supporting.c that I'm looking at now. Things that are in here is there's the declaration of that global variable, which was made truly global by the extern in the .h. I just wanted to show you that syntax, but I'm not actually using it. There is a module level variable, which is visible anywhere in this file because it's defined outside of a function. There's an internal function, which means like inside this function you could call it. And then, no surprise, here is the example function that we gave you before. So it did 2 times x. So what some people like to do is they like to write their own modules so that they can break their code up into more pieces. Let's go ahead and make another module, but with a different file name. So I'm going to right-click and go through this process again. That's the best way to learn something. I'm going to say new supporting.c, and I'm going to call it, I don't know, math helper. So I've got a math helper.c. The .h file needs the exact same name, so I'm going to take supporting.h and I'm going to rename it to math helper. And so that made mathhelper.h, mathhelper.c. There are a couple changes you need to make if you change the name. So for example, the word supporting here should say math helper. And so if math helper is not defined, then define it. So that was the first quick change we needed to make. And then the other change we needed to make is instead of including your header file, you want to include math helper. And so that includes the appropriate header file for this one. Now, these have the same names as the other one, so I'm going to call them example function 2, and I'm going to just blow away these things that I'm not using that are in the .h file because I do not want duplicates. I'm going to also delete it here, this global variable. So in this math helper, I'm going to make it quite simply return 20 times x. So that's example function 2. So over in writing functions, I can say I've got supporting.h, and I've got some functions there I'll use. I've also got math helper.h, and I've got some functions over there that I can use. And so now if I wanted to run it, I'll say example function 2, and I'll just print out its result as well. So hopefully this one says 10, and then this one will say 100. And then I didn't clear the window, so it'll actually say 10 twice. Oops, it didn't like something. Okay, it looks like what it didn't like is it didn't like me having the same names for private function, so I deleted private function out of math helper. All right, so now I'm looking at this result, and I can see that it says result of function is 10, and then result of function 2 is 100. So I'm not going to go into any more detail than that. But I just wanted to mention that if you did want to use this organizational structure to make separate .c and .h files, you can totally do that. And then if you look at the code in detail, there are things you can do with global variables and public pound defines, and you can use them to your heart's content or not. You'll never be graded on them, but it's a tool you could use for your projects if you wanted. All right, that's it. See you next time. Bye.